All right, in this last video, we are going to go through and we are going to sort out our different graphs in these different figures. So I'm going to use red for my original function. I'm going to use blue for my first derivative, and I'm going to be using green for my second derivative. All right, let's do it. So with these graphs, because they are so cyclical, I'm going to be paying attention to a couple of different things. So I'm going to be paying attention to where you have critical points, so where you have maxes and mins, and then also what the slope is between those critical points. Is that slope positive or is that slope negative? So if I'm starting from this largest one, I have a couple of critical points here, right? Which means that if this is my original function, my first derivative would have to cross the x-axis, cross at 0 for that. But then in between, I also have to pay attention. So if this is my original function, my graph would have to be in the negative section and then hit the x-axis, then go to the positive section, then hit the x-axis, negative section, x-axis, positive section, x-axis, negative section. Okay, so we would be looking for either the dark solid line or the dotted line to start in the negative section, and then here we would want it to hit 0. So my dark solid line doesn't start in the negative section, so I can kind of ignore that. My dotted line does, but it doesn't hit 0. It doesn't cross my x-axis at its critical point. So I don't think either of these things are the derivative of this biggest wavelength, which means to me that this would have to be my second derivative. Okay. So we'll double check it at the end. Oops. I'm doing my second derivative in green. Okay. We'll double check it at the end, but I think this has to be my second derivative because neither the dark solid line or the dotted line, whoops, is the derivative of this. Okay. So I'm going to call it my second derivative. All right, so now if I look at these other pieces, I'm going to do the same thing. So let's test another one. So let's test the solid dark line and see if that's the original function. So that means that my original function would have to start in the positive section. And then it would have to have a critical point because it has a horizontal tangent line there. Then it'd have to go into the negative section, horizontal tangent line, positive section, horizontal tangent line, negative section, horizontal tangent line, positive section, horizontal tangent line, negative. So I would be looking at either the dotted line or the solid green line to be the derivative of my red function. So if this, which one of those things, my green line does start in the positive section, and then it does cross the x-axis, it has a 0 at that critical point. Then it goes into the negative section, then it has a critical point, then it goes into the positive section, and then it has a critical point. Amazing. So I'm going to go with that this red function, which it actually won't end up being red, but this solid short line, its derivative is this giant green one. So that would make this the first derivative, because the blue line's derivative is the green one, which means that this would have to be my first derivative. Kind of worked backwards on this one, didn't we? All right, so now let's look at this dotted line and make sure that it's my original function. Okay, so my original function, it's increasing until this point, which means that my first derivative graph should be in the positive section. Yep. Then it's decreasing until this point, which means my first derivative graph should be in the negative section. Yep. And so on and so forth. Okay, so that makes sense. And then let me just double check it with the concavity. So it looks like, because then that would be a great way to double check it against the second derivative graph. So I am concave down from, it looks like here to here-ish, which means that my second derivative graph should be in the negative section, which it is. Whew, I think we did it. So our first derivative, or excuse me, our original function is actually the smallest, shortest graph. Then we got our first derivative, and then we got our second derivative. All right, let's move on to the next one. All right, so in this guy, I'm going to do a very similar thing to where I just pick one, so I'll probably pick the top one, and I'm going to look at its critical points and then what's happening between those critical points. So here's a critical point, here's a critical point, and critical point. And then I'm looking for its derivative graph, which would be in the negative section, then positive, then negative, because these slopes are negative, these slopes are positive, these slopes are negative. So which one of these lines, either the light solid line or the dotted line, are starting at 0 here, then in the negative section, and then they hit 0 here. Oh, I should be drawing these with blue too. So here, 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 and here. Okay, so it's in the negative section until here, then it's in the positive section until here, and then it's in the negative section until here. So I think that's good. I think that this will be our first derivative. Actually, I don't know if it'll be the derivative, but it could be this could be the first derivative, this could be the second derivative. We have to double check on this last one. All right, so on the last one, let's say that this one's maybe my second derivative. That means that in my original function, so from like here-ish to here-ish, it's concave up, which would mean that my second derivative graph would have to be in the positive section, which it is. From here until here, it's concave down, which means my second derivative would have to be in the negative section. Whoops. Which it is. And then we go concave up again. Yep, makes sense. And then concave down on this side. So it makes sense. Yep, I think we got it. That's so messy. I don't like all those little tangents still being on there. Get out of here. Okay. All right, let's go ahead and look at our last two examples. So in this one, I'm just going to pick one of them and see if it makes sense. So I'm going to pick this one, this dotted line, because I noticed a couple of things. First of all, it's increasing only. So let's make this my original function, which means it's increasing only, and it looks like it's basically only concave down. So I need to be looking for a graph. My first derivative graph would have to be only in the positive section. So if this is my original, I think that would make this my first derivative because it would be only in the positive section. But then my my second derivative would have to be only in the negative section, basically. Unless you could justify that this is concave up right here, but or else this doesn't make sense, because if this is my second derivative, then that means my graph was concave up until this point and then concave down afterwards. And I don't think I necessarily agree with that. All right. So we messed it up. Let's see if we can try again. Let's pick a new one. So let's say that this solid line is your original function. So this is only decreasing. So only decreasing, which means its first derivative, oh wait, just kidding, until about right here-ish. I would say then it goes to increasing. So it is decreasing until here, and then it goes to increasing, which means my first derivative should go from negative, which this one does, till here, and then it goes positive. So I would say that this is G prime. And then again from here, I have to just double check and see whether or not this would match as my second derivative. So if G prime, it looks like it's only increasing, so my second derivative should only be in the positive section. Now here's where I have a little bit of a problem with this, because if I'm estimating the slopes of these tangent lines, right, I would say that this is a pretty positive slope. Like I would say that that's like 4, and then it might go down to 3, and then 2, and then 1, and so on and so forth. So they're all positive, but they should start high and get, like, my graph should start in a more positive section and then get lower. Whereas this line right here starts almost at 0 and then gets a little bit positive and then goes back down. So I would say it's like the y values of this graph are 0 and then 1 and then 2 and then 3, and then they start going back down. So it doesn't start at 4, 3, 2, 1. It starts almost at 0. Okay, so I think we've done one more mix up, so let's try our last opportunity. All right, so let's go with this being G. So if this is my original function is concave down, And then maybe it goes concave up at the end here, which means, oh, sorry. My original function is increasing until here, and then it's decreasing. So that means its first derivative would have to be in the positive section, then hit 0, then go in the negative section, which would make this one the first derivative. Positive section, hit 0, goes in the negative section. Okay. And so then I would have to just make sure that this dotted line matches my second derivative. So this is concave down, concave down, concave down, concave down, until maybe here it goes concave up. So concave down would be in the negative section, negative section, negative section, negative section until here, and then it goes concave up maybe just slightly. That would be okay. And then also you can compare it for your G prime. So my G prime is decreasing, 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 decreasing until like here-ish, and then it's increasing, 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 which means that your second derivative would have to be negative, 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 negative until here, and then it goes positive. There, I think we did it. All right, and this last one, G prime is not shown, so we're going to do it based solely on your concavity for the most part. So I'm just going to pick one. So let's say this solid line. This is concave down until about here, and then it's concave up, which means that my dotted line would have to, if it was the second derivative, would be in the negative section of your graph until here, and then it would go into the positive section, which it doesn't do. It's all basically in the positive section. So let's try it the other way. So let's try making this G. Let's see if that works. Concave up, concave up, concave up till about here, then concave down, which means my second derivative would have to be positive, positive, positive until here, and then go negative, which this is in the positive section. Then it goes negative. So there we go. Oh no, stop. So that is your second derivative. Awesome. Nice job, you guys. All right, we're going to practice with this a lot and basically, like I said, re-encode this information in a lot of different ways. So this will not be the only time we work with this. Thanks, guys.